Hello everybody, welcome to another lesson. In this lesson we're going to be doing more solving of quadratic equations, but this time we're going to be doing it by completing the square. So for context, our previous topic was solving quadratic equations by factoring, and now we're going to be doing it by completing the square. So really there's a few different ways to solve quadratic equations. You can do it by factoring. You can do it by completing the square. You can do it by quadratic formula. Which we haven't done yet, but we will. And then there is kind of an extra way to do this, which is like kind of just like directly, but that method is going to be related to completing the square. But you'll see what I mean in time. So how do we solve something by completing the square, or why would we choose to do what's called completing the square? Well, any quadratic equation that can't be solved by factoring, if it cannot be solved by factoring, it can be solved by completing the square, okay? These are the steps that you would take. I'm going to be modifying those steps a little bit when I teach you how to do it, because I find this method a little bit hard to remember. But I'll just read them out just so you know what we're eventually going to do, even though we do it in about 2 pages from now. It says we're going to want our equation in this standard form, which is normal. If a equals -1, we're going to divide each term by a. So you'll see that happen later. We'll divide everything by that leading coefficient. Then we're going to take the middle number, b, the coefficient for the x value, and square it. Actually, we're going to divide it in 2, and then we're going to square it. And then we're going to add the result to both sides. So again, you're already probably feeling a little bit lost, right? So before I go any further with this, we'll just move on. And oh, by the way, this actually isn't standard form. It's equal to a constant, but we'll worry about that later. These steps can be a little bit frustrating to read through. So let's just go ahead and I'll set up the topic by giving you some sort of base ideas, some introduction to the topic, and then we'll actually do the complete the square. So the first thing we're going to do is consider what's called perfect square trinomials, and then we're going to find the roots of some quadratics. So first things first, perfect square trinomial. What the heck does it mean to be a perfect square trinomial? Well, it's a trinomial which has 2 equal binomial factors called a perfect square. Easier for me to explain. So all of these are perfect squares because of the pattern that we see here. We see a couple things. First things first. This is our whole trinomial, but if you look at the middle number, if you divide it by 2, and that's actually the same as saying our b value divided by 2, or in other words, our b value divided by 2, it gives us our -1. So basically, a perfect square trinomial is a trinomial which has this relationship when we factor it out. Let's look at the same thing here. +4 is our b value. Divide it by 2. You get +2. If you factor this out, if you factor this whole thing out, you're going to get x plus 2 and x plus 2 as well. -6, -3. And finally, +8 and +4. So at the end of the day, really what a perfect square is going to do for us, it's something that has this pattern. And by the way, there's one more pattern, and I'm throwing a lot at you right now, but I will summarize everything. If you take this middle value, the b value, if you divide it by 2, and you square it, so 8 divided by 2 is 4, square that, you get 16. That is another really interesting relationship that we have for perfect square trinomials. And believe it or not, they're going to help us solve our equations that are to come. So let's look at what else it's saying. It's saying for each square trinomial, the square of half the coefficient of x equals the constant term. What this is trying to say, I'll try to break this up for you nicely, okay? Just look at the first equation here. Just look at this, all right? What is the middle value? The middle value is +4. That's our b value, right? And ax squared plus bx plus c. This is our b value. So if b is 4, what's b divided by 2? What's b divided by 2? It's 2, right? And then what is b divided by 2 all squared? Well, if b divided by 2 is 2, you square that, you get 4. So what it's trying to say is you divide it by 2 and square it. You get this value. Okay? b divided by 2 and squared. b divided by 2 and square it, you're going to get that value. You don't need to fully understand why we're doing this yet. I just want you to recognize what it means to be a perfect trinomial. Let's try it for the second case. Maybe try it yourself. Look at this number, -6. We want to check to see that this whole thing is a perfect square trinomial. What is this number? That's our b value. So that means that b equals -6. What is b divided by 2? It's -3. What's b divided by 2 but squared? It's -3 all squared, or 9. Hey, we get that pattern again, hey. Divided by 2 and square it, you get a 9. So we've kind of confirmed that it is indeed a perfect square trinomial. And this is what it's trying to say here. This whole thing here is just saying b divided by 2 squared. It's just not a helpful way to do it. I really don't like the way that it's written here. So let's do a few examples so you can see where we're going with this, okay? And again, this is like introduction to the topic we're going to go to, but it doesn't mean it's not important. It says, is x squared minus 10x plus 25 a perfect square trinomial? And if so, what are its factors? Well, this is actually really nice and easy. All we need to do is, for our first step, check that our b over 2 all squared equals 25. Okay? Where does the 25 come from? It's this. So we take our middle value. This is our b. If we take it, divide it by 2, and square it, we should get 25. So let's see. Our b is -10. Our b divided by 2 squared would be -10 divided by 2 all squared. Or in other words, -5 all squared. That would give 25. Hey, excellent. Yes, it is a perfect square trinomial. Okay, cool. And again, why do we know that? How do we know that? It's when you divide the middle number by 2 and square it, you're going to get that coefficient at the end, 25. It says, if so, what are its factors? How the heck do I find that? Well, I will tell you, there's a very nice, easy rule for it. The factors are going to be x, and you've got a squared. What goes here? You just add b over 2. So it's literally your b value divided by 2. So our factors in this case are x minus 5. If you want to know where the minus 5 comes from, it's the fact that b equals -10, so b over 2 must be -5. Okay? Hopefully you're able to make the pieces connect here. Really all you needed to write was this. You could have jumped straight to this. You'll get better and better with this idea, but I like to start big and then work down, make it smaller and smaller as we go. So the second question, maybe try it yourself. Is x squared minus 3x plus 9 over 4 a perfect square trinomial? So the way I'm going to do this, when we're dealing with perfect square ideas, really the star of the show here is this b value. So I usually do 3 things. I'll state what the b value is so that it's completely obvious what it is. And then I'm going to divide it by 2. So -3 divided by 2 is -3 over 2. That will give me my factors. In fact, I could put my factors down right now if I wanted to, but I'm going to wait. Now, what is that number, b over 2, all squared? In other words, what's -3 over 2 all squared? Well, remember from Unit 1, I guess, you can distribute this. Sorry, I got something stuck in my throat today. -3 squared is 9, positive 9. 2 squared is 4, so 9 over 4. What does that tell us? Well, the number in the middle, -3, divided by 2 and squared, should be equal to this. So they're the same. Yes, it is a perfect square. Perfect. Excellent. Perfect. If so, what are its factors? If you were listening before, the factors are really easy to get. It's x minus 3 over 2 all squared. Now, how did I get that? What magic reason was I able to use to get that number without doing any work? Well, it's the properties of perfect squares. b over 2, the middle number, divided by 2, so negative 3 over 2, that goes in as the factors. Okay, the factors are x minus 3. It has a double root, really. So that's our final answer. These are the factors. If you wanted to check this, so maybe you wanted to do a little check. Take x minus 3 over 2 and break it into two pieces and expand it out. Do FOIL on it, okay? First, outside, inside, last. This times this, and this. This times this, and this. What you would get is x squared minus 3 over 2, x, minus 3 over 2, x, plus 9 over 4. And if you simplify that by combining like terms, you would get this. Why is that important? Well, because that is my original expression. So the factors, when you expand them back out, give you the original expression. That's a good thing. Okay? So just in case you're confused, the answers are yes, it is a perfect square, and its factors are just that. You know, you could write it in that form, or you could write it as a double root. It doesn't matter as long as you get the final answer. So let's move on. Let's try the next question. Is x squared minus 8x plus 1 a perfect square trinomial? If so, what are its factors? Let's just take a look. What we care about, again, is the middle number. That's our b. X squared, b is negative 8. That means that b over 2 is negative 4. But what we really need is b over 2 all squared. So it's going to be, this is b over 2, negative 4. We're going to square that. So negative 4, square it, we get 16. Is that okay? It looks like a perfectly reasonable result, but unfortunately, actually, it's not okay. Because this should be equal to this. So it's not a perfect square. And so we're not going to deal its factors. We're not going to figure out its factors in the normal way. So it's not. It says, if so, what are its factors? We're not going to factor. So long story short, how do you know if something is a perfect square trinomial? A perfect square trinomial is a trinomial where a couple things are true. If you divide the middle number by 2 and square it, you should get the coefficient that's next to it, the constant. If that's true, it's a perfect square. Also, if it's a perfect square, if you divide the middle number by 2, that will give you your factors. Just take x plus that number. I'm going to do one more thing as a setup to completing the square, and then we'll actually do some questions on completing the square. It says, the last step with any completing the square problem requires you to take the square root of both sides of the equation and solve for the variable. This should always result in two solutions. So what it means is, if you have something in this form, a squared and then a constant on the other side, or even this squared with a constant on the other side, we can solve it. Just watch what happens. Let's just take the first case, okay? X squared equals 9. Well, x squared equals 9. What can I do? I can square root both sides, which you've definitely done before. Where'd my 9 go? You've done that before. The difference is, what we're going to have to do when we do these problems is a little something extra. I'm sorry, I'm fighting with my Surface today, my device. You need to include plus and minus. So don't forget to put a plus and minus for the square root. What this means is, you know, the square root of 9, you can get it in two ways, right? Let me just get a little further in this question. The square root of x squared, I'm so sorry, why does that keep happening? is x. But on the other side, we've got to say plus or minus. What's the square root of 9? You can put it on a calculator. It's 3. Why does that work? Well, it's because 3 squared is 9, but there's actually two solutions. If we took negative 3 and squared it, we would also get 9. So that's why there's two solutions to this, which is why we have to consider both when we're plus and minus, especially because normally quadratics have two solutions, right? So what this gives us, it means there's two solutions. There's what I call the x equals 3 solution, and there's the x equals negative 3 solution. And what I'll normally do is I'll call it x plus and x minus. So this little plus and minus here, right? Maybe I'll color code it. Plus, I write, okay, well, let's just forget the plus and minus, just treat it as plus. What does it give me? It gives me positive 3. And then the bottom, consider what would happen if I got my negative. I took the negative instead, so x would now be negative 3. Those are my two solutions to the equation. All good? Hopefully that makes a bit of sense. Now some of you might look ahead on this and say, wait a second, I can do this better. Maybe you could take the original expression and rearrange it. So the original expression is x squared equals 9. You could rewrite that as x squared minus 9 and then go jump right into difference of squares. So you do this. And then once you've broken it up by difference of squares, you could hopefully make the jump to say, hey, what are my two x values? Well, it must be x minus 3 and x is 3. And that's perfectly legitimate. You can do that. I usually like to do the square root myself, but it's up to you which method you want to choose as your favored method. As long as you don't break math, you're okay. Let's do the next question. We've got a little bit of a weird number here, x squared equals 17. So how are we going to deal with this? Well, I'm going to deal with it the exact same way I dealt with the last time. I'm going to square root both sides. Square root this guy, square root this. What does it give me? It's going to be plus or minus 17, okay? So it's really easy to write this, but really what I mean is it's plus or minus that. So x is plus or minus the square root of 17. Now you could probably write that in some fancy way, but honestly that's enough. The best thing you should do though is if you see a plus or minus, it's better to split them up. Split the solutions up into two pieces because we have two roots for quadratics. If it's plus and if it's minus. And that's our final answer. So they don't need to be long questions. They don't need to be complicated solutions. You just need to follow the right method. All right, let me do the last one. I'll give you a chance to take a look at everything in one place while I draw a line. And maybe see if you can tackle this one. Pause the video, see how far you can get before getting stuck, if you get stuck at all. I'll show you what I would do. First things first, I would get the square root of both sides. All right, so I have x minus 2 all squared equals to 16, but I'm going to square root both sides. And by doing that, I need to make sure I have a plus and minus for the constant term. And that'll make sure that I get two solutions when I finish. The square root on the left side cancels the square. Cancels the square. That leaves us with x minus 2 on the left. On the right side, plus or minus square root of 16. Square root of 16 is 4. So plus or minus 4. What do I do next? Well, treat it like you normally would. You're trying to solve for x. If you want to solve for x, bring the constant to the other side. I should be more specific. I usually like to put the constant right in front. It doesn't matter. Maybe I'll do what I first was thinking. Put it over here. Look what happens. We have x equals plus or minus 4 plus 2. And now we have a bit of a situation. If you've never dealt with this before, you might be a little bit confused as to what to do. But never fear. Once you get to a point where you don't know what else to do, or you don't know how much further to take it with that plus and minus, take it in two cases. All right? You're going to say, well, what if it was plus 4? And you're going to say, what if it was negative 4? So let's do the plus case first. We have plus or positive 4 plus 2. What's 4 plus 2? It's 6. So our answer is 6. Let's do the negative case. What if it was negative 4 plus 2? What's negative 4 plus 2? Negative 4 plus 2 is negative 2. And now we have our two distinct solutions. One situation where we have our positive 4 giving x equals 6, and then x equals negative 2. That's the solution to this. And now it is the moment of truth. We have built up our methods for solving things by completing the square, but I haven't done a completing the square question yet. I haven't explained what it is. So now it's time to do this. Okay, these examples, it doesn't say it in the question, but what we need to do is solve by completing the square. Completing the square is probably the trickiest method for solving in this course, but if you follow my recipe, you'll be okay. First things first, let's make sure you can't solve this by any other methods, okay? If you could, why the heck would you choose something like completing the square, okay? And turns out, if you look at the factors for 8, think about 8. What are the possibilities? 1 and 8. Can they add or subtract to make 6? No. 2 and 4. All right, that's a good contender, 2 and 4. Maybe they could be, the bigger sign is the 4, smaller factor takes the other sign. Oh, wait, that doesn't work. Because look, negative 8 and plus 6. Negative 8, you'd have to have two numbers that add together to make negative 6, but they multiply to make negative 8. That doesn't exist. So this can't be done. What are we going to do? We're going to use another method. And if we can't solve by regular factoring, we can almost always solve by complete the square. So let me just summarize what we're doing. So it can't be factored by our other methods, which means I can't just factor it directly. It's not a trinomial that I can deal with. I can't do difference of squares. I can't do difference of cubes or sum of cubes. I have to do something new called the completing the square method. I'm going to give you my recipe for this, okay? If you want to, you can go all the way back 2 pages ago and follow these steps. There's nothing wrong with that, but I'm going to show you a method that I learned a while back, and I find it easier to think about, okay? So I'm going to write the instructions out. The first instruction is to make sure you have a leading coefficient of 1. If it doesn't, you need to divide everything by the leading coefficient. The second step is something I call shove the constants. Or in other words, move all constants to the right side. So in this case, that's the negative 8. We would toss that to the right side. The third step is to add b over 2 squared to both sides. That'll make more sense when we do it. The fourth step is actually called complete the square. And that's where our factoring information that we did a couple pages ago will come into play. But you'll see. And then the fifth step, the final step, is to square root both sides and solve. Are you excited? Are you ready? I hope so. Let's do it. Okay, let's follow our method. First things first. Look at this. Is the leading coefficient 1? Yes, it is. A is 1. We're good to go. A is 1. Good thing. Second, shove the constants. Okay, yes, sir. Bring the constant to the other side. You get an 8 on the right side. Positive 8. Now we need to get our b over 2 all squared. We need to add that to both sides. So what I'll show you to do, our negative 6 here, a little side work, little work on the side of the page. B is negative 6. B over 2 is negative 3. B over 2 all squared must then be negative 3 all squared, which is 9. Make sure you take your time, pause the video, do that on a calculator, make sure you know where those numbers came from. It is absolutely important. Now that I've done those 2 steps, actually 3 steps, I'm in the middle of this 3rd step, I need to add it to both sides. This is the beauty of this method. Watch what happens. X squared minus 6x. Add that term I just made to the left side. On the right side we have 8. Add that to the right side. What the heck does this mean? Well, this now is a perfect trinomial. I've built my own perfect trinomial like we had a couple pages ago. I've made sure that it fits that form. And if it fits that form, I know that I can take the factors. I can build the factors properly, or I can use this idea to complete the square. What kind of gibberish am I talking about now? Well, watch this. It's magic. Take x, put that number there, minus 3, all squared. That's my whole left side. That perfect trinomial can factor down into that. Now, before you freak out and say, wait, sir, I really don't know what's going on here. Well, let's go back. I'll show you when we did that. Remember? The factors, you take that number, you divide it by 2, you get this. That's its factors. Or even way back here, I think. Yeah, take this number, divide it by 2, you get its factors. That's the beauty of the perfect square. And so we can actually make our lives easier once you've made it complicated for a little while. So this negative 3, it absolutely is related to this negative 3. It is in fact the same thing. What do I do to the right side? Well, it's 8 plus 9. All I can do is add them together. And then what do? I square root both sides. All right, that's what we did last. Square root both sides, you get plus or minus square root of 17. I'm starting to run out of space, but I don't need very much more. Bring it to the other side. Let me write the full thing. This is 3 plus or minus square root of 17. What that means for us, and this is the very end now, if I take the positive version, it would be 3 plus root 17. If I take the negative version, it'll be 3 minus root 17. Those are my roots. Let me clean this up a little bit. Okay. So if you're having trouble seeing that, I'll zoom in so you can see everything now. Sorry for any of you using the small screen. I will go back through my steps. Shove the constants to one side. Add b over 2 all squared to both sides. Factor this, otherwise known as complete the square. Square root both sides. Square root left side, square root right side, and solve for x. All right, some pretty heavy stuff. That's not easy. That's not easy to do, but that's okay. No big deal. We'll keep working on it until we get as much practice as we can. So what I'm going to do next in this video, I'm going to do number 3, believe it or not. Number 3, and then I'm going to do number 2. And we'll end there today, and we'll do the rest of the practice in class, in the next class, okay? So I'm going to keep my instructions here. Sorry for making this a little bit small, but what I'm going to do is leave these instructions up here so that I can use them. Now, leading coefficient must be 1. Oh, I said I was going to do 3 first. My bad. So hopefully you've got those written down. I'll follow the method down here. Let me paste it. Okay, I pasted it in just because I wanted you to be able to follow along. So let's go step by step. Step 1, the leading coefficient must be 1. It is. There's a 1 here, whether we can see it or not. So we got a equals 1. We're good. Now, second step, shove the coefficients. So shove the constants, I should say. Move all the constants to the right side. Okay, I can do that. X squared minus x equals 6. Third step, add b over 2 all squared to both sides. Okay, what's our b? Our b, it doesn't look like anything right now, but our b is actually negative 1. That divided by 2 is negative 1 over 2. We're going to use that later. If you remember, we're going to use that later as a factor. And then b over 2 all squared, what's that going to be? It's 1 over 2 all squared. That's 1 over 4. If you don't believe me, I'll do another piece of work. Negative 1 over 2 all squared is negative 1 squared over 2 squared. maybe you can't read that. 1/2 all squared, negative 1/2 all squared, gives this. That's where the 1/4 comes from. Am I following my recipe? What have I done so far? I have done b squared over 2 all squared, or b over 2 all squared. I haven't added it to both sides. So I'm going to add it to both sides now. X squared minus x plus 1/4 equals 6 plus 1/4. This looks complicated. Try to relax. Try not to freak out. I'm trying to keep it as simple as possible. Remember that this is our perfect square trinomial now, which I can make equal to our factors of the perfect trinomial. X all squared. What's going to go there? Take time to think about it. What's going to go here? It's the b value divided by 2. It's just this middle coefficient divided by 2. So it's 1/2 minus 1/2. On the right side, I simplify it. What's 6 plus 1/4? You can do it on a calculator. 6 plus 1/4 is 25/4. 25/4. Now I can't go any further. I need to square root both sides. Just going to rewrite everything so that it's really clear. Square root both sides. I'm at this step. I've already done the completion of the square by factoring. Now I'm going to square both sides and solve it. Square root, plus and minus comes out of that side. The left side, the square and the square root cancel, leaving me with x minus 1/2. On the right side, plus or minus square root of 25/4. Toss that into your calculator and simplify it. You should definitely get plus or minus 5/2. If you don't want to use a calculator, how do you get that? Well, the square root of 25/4 is the exact same thing as the square root of 25 divided by the square root of 4. Square root of 25 is 5. 5 times 5 is 25. Square root of 4 is 2. Because 2 times 2 is 4. So that's where this comes from. All right. Now what do? We only have really one step left to do. We'll move the 1/2 to the other side. It'll end up being 1/2. 1/2 plus or minus 5/2. And it's not so nice to leave our answer like that. It's probably a good idea to simplify. So that means if we take our positive answer, make some space. Our positive answer, 1/2 plus 5/2. If you toss that in a calculator or just work it out, you'll get 3. Much nicer. Take time to pause the video and make sure you can get a 3 from that, okay? If you can't, fire me an email. I'll help you out. And what if I take the negative version? That's 1/2 minus 5/2. Let me make some space. So this is the plus version. This is the negative version. What is 1/2 minus 5/2? If you work it out, it's actually negative 4/2 or negative 2. Finally, this plus and this minus is based on the plus and minus here. Plus and minus. I said that before, but just in case it's new to you, this idea is new to you, then I wanted to make sure that I'm helping you out every step along the way, wherever I can. So let's go ahead and try number 2. I'm going to move my oops. Let me just pause the video. I'll tidy this up for you. Okay, I just jumped back to number 2 just because I wanted to clean the page. The instructions, hopefully you have them written down for now. I'm not going to write them on the page because it just makes it messy. But try this. See what you can get. Get as far as you can. Pause the video. See how far you get. If you do that and come back, you should have negative 4 plus or minus root 20 for the answer. So just, if you wanted to give it a shot, knock yourself out. See if you can get this as the solution. But I'm going to go through the steps here. First things first. The first step is leading coefficient of 1. The coefficient here, the leading coefficient, is not 1. So the first thing we need to do is divide everything by the leading coefficient. Okay? This is a 2, dividing everything by 2. including the 0. That doesn't do anything though, it doesn't cancel anything. And that'll simplify everything. The other way of looking at this, which I did in class, is to factor it out. Actually, I'm not even going to show that right now, I'll show that in a second. This is x squared plus 8x minus 4 equals still 0. So now it's in perfect squared form. I just wanted to mention what I was going to talk about a second ago. So we started right with 2x squared plus 16x minus 8 equals 0. If you pull a 2 outside of this as a common factor, you get this. And then if you divide everything by 2, you get x squared plus 8x minus 4 equals 0, which is the same as this. Sorry, same as this. So it's just an alternate method. I'm going to just have a little dream sequence here so that you know it's just a little extra work, maybe an alternate way if you prefer that method. All things considered, though, I've got a form that I like. All the coefficients, or the constants I should say, are on the left side. I need to pull those to the right side. So that would be the next step, the shove constant step, step number 2. All right, now my constants are all on the right, and what do I do now? I need to do my whole b thing. All right, so let's make a little bit better colors this time. Plus 8, okay? So b is 8. My second step, b over 2, what's that going to be? That's going to be 4. What's 4 squared? 4 squared is 16. What am I going to use those numbers for? Well, first I'm going to add this 16 to both sides, because that's my third step. Get that number and add it to both sides. Plus 16 there. 4 plus 16 here. What that does is, remember, even if you're not really sure what's happening, it's important to remember that I've made a perfect trinomial here. If I divide this by 2 and square it, I get 16, so this is a perfect trinomial, which means I can factor it nicely, okay? It factors really nicely. The factor is just a plus 4, all squared. And you could get that by your regular methods. You could take 16, figure out your factors of 4 and 4, and then decide that it's going to be a plus 4 and a plus 4. That's perfectly fine, but this method is faster, because you just divide the middle number by 2. Okay, it came from here. What about the right side? 4 plus 16, that's a 20. What do I do next? Step 5, square root both sides and solve it. Square root the left side deletes the square term. Square root the right side gives me plus or minus root 20. What do I do next? Well, I'm going to bring that 4 to the other side. Boop. That gives me negative 4 plus or minus root 20. In some math courses or textbooks, you can leave it at that. I would rather give the full solution. So this plus and minus actually gives 2 solutions. So if x was plus, what would it be? It would be negative 4 plus root 20. If x was negative, what would it be? It would be negative 4 minus root 20. And that's enough for me. It can simplify more. Some students prefer to write it this way. Negative 4 plus 2 root 5 and negative 4 minus 2 root 5. It's okay if you want to do it, if you want to write it out that way, but not needed. It's a little easier, a little less work to do the way that I showed first. Okay, so that is completing the square. Let me show you the whole page at once. We've done the same method 3 times in a row, whether you believe me or not. Okay, we followed the same 5-step process, making sure the leading coefficient is 1, shoving the constants to the other side, adding the middle term over 2 squared to both sides, completing the square using the factoring idea, and then square rooting both sides and solved. So it's a heavy class today. Don't worry if you feel overwhelmed. It's normal. What we're going to do in our next class is these 3 practice problems, okay? So I recommend you look at those practice problems before class so you have a good idea of what we're going to do next. That's it for today's lesson, everybody. I hope you have a great day, and I'll see you next time.